Hello, math people. My name is Andrew Burford.
And I'm Vince Lee, and today we're going to be teaching you about factoring.
So today we're going to be learning the following techniques for factoring. We'll go over factoring by grouping. We'll go over splitting the middle term, and that's used when a does not equal 1 in the standard form ax squared plus bx plus c. We'll go over the difference of how to factor difference of cubes and how to factor sum of cubes. And we'll also make sure we review the difference between factoring expressions and solving equations by factoring.
So, as a review, you should already know a few concepts, and those would be easy factoring of quadratics when a is equal to 1, how to know you're done factoring, you should know how to factor a difference of squares, and you should know to factor out a GCF. If you don't know or you're not familiar with any of these concepts, make sure to check out another video on our channel, or you can search elsewhere on the internet for help. The first concept we'll be going over is the difference or sum of cubes. So when you have a cubed minus b cubed, you can factor through difference of cubes. And as you may have guessed, when you have a cubed plus b cubed, you can factor through sum of cubes. So to factor this way, you just have to remember the acronym SOAP, same, opposite, always, positive. So if you have a difference of cubes, for example, a cubed minus b cubed, you factor this into a minus b times a squared plus ab plus b squared. And if you look at the signs, both the minus stays the same. Plus and minus are opposites, and then the last one is plus because it's always positive. So you might want to take a moment to pause and try to just apply this to x cubed minus 27. And as you can see, x cubed minus 27 is the same as x cubed minus 3 cubed. So then you just basically substitute into this formula, and then you end up with x minus 3, x squared times x squared minus 3x plus 9. So for sum of cubes, you have almost the same thing, except as you can see, the signs are reversed because the pluses are the same, minus and plus are opposites, and then the last one is still always positive. And here's another example for you guys. Try to factor x cubed plus 64, and you might want to take another moment to pause right here. And this x cubed plus 64 is the same as x cubed plus 4 cubed, which again we just substitute into here, and then we have x plus 4 times x squared minus 4x plus 16.
So when you factor by grouping, you typically end up doing one of two things. You either find two pairs of terms that have proportionate coefficients, and this allows you to factor out a GCF, or you find two perfect square trinomials, and then you can use difference of cubes to finish factoring. So when you factor with proportional coefficients, you'll see an equation that looks sort of like this one here, where you have x cubed minus 5x squared plus 3x minus 15. So you'll notice that the first two terms, the coefficients are 1 and 5, and the second two are 3 and 15. So 1 and 5 and 3 and 15 are proportional, so this means we can factor by grouping together the terms. So in the first group, you can factor out x squared, and this will give you x squared times parentheses x minus 5 and parentheses. And then in the second group, you can factor out a 3, and this will give you 3 times parentheses x minus 5 and parentheses. So now we have two terms, and both of them are multiplied by x minus 5. And since they're both multiplied by x minus 5, we can factor that out as a GCF. Now that expression is factored into x minus 5 times x squared plus 3. And note that this is just, again, factoring the expression, not solving an equation. You can also do grouping with perfect square trinomials. So let's say you have an expression like the one above. So you have r squared minus m squared plus 4m plus 2rx minus 4 plus x squared. So if you rearrange these terms, you will notice that you have r squared plus 2rx plus x squared. And this is a perfect square trinomial. And then we also have minus m squared plus 4m minus 4. So what you'll want to do is factor out a negative on the right side, and that will allow you to make sure you're going to be able to factor a difference of squares, because you can't factor a sum of squares. So r squared plus 2rx plus x squared factors out to r plus x squared, and then m squared minus 4m plus 4 factors out to m minus 2 squared. So now you'll notice we have a difference of squares. So we can factor this like any other difference of squares, and it will end up factoring out to parentheses r plus x plus m minus 2 and parentheses, and then in parentheses r plus x minus m plus 2. And again, this is just factoring out an expression, and we're not solving any equations here.
So the last concept relating to grouping we'll be showing you today is splitting the middle term. And this is used when factoring when a is not 1 and there's no GCF, so you can't make a equal to 1. So you find the factors of c times a that multiply to b. So for example, if you have 2x squared plus 11x plus 15 equals 0, c times a is 2 times 15, which is 30. And the factors of 30 that add to 11, which is b, are 5 and 6. So you split the middle term into the two factors, and you end up with 2x squared plus 5x plus 6x plus 15. So notice that this allows the coefficients to be proportionate, so you can use the technique you learned earlier. And in this case, you'd pull out x from the first group and then 3 from the second group, leaving you with 2x plus 5 as the GCF. So you end up with 2x plus 5 times x plus 3 equals 0. So notice in this case, we actually have an equation, so you should completely solve for x. In this case, x plus 3 equals 0, so x equals negative 3, and 2x plus 5 equals 0, so x equals negative 5 over 2.
Thanks for watching.
Make sure you like, comment, and subscribe. Check out other videos on our channel for additional math help, and we wish you good luck on any future math assignments you may have.